Welcome to the Print Pod. Journalist Sandhya Ramesh wrote an article titled "Through Indian Telescope, Astronomers Spot Mysterious Birth of Stars in Distant Dwarf Galaxies." I'm Revti Karan and I bring you the podcast version of this article. A team of astronomers from India, the United States, and France, led by Pune's Inter-University Center for Astronomy and Astrophysics, has observed the formation of new stars in the outer regions of distant dwarf galaxies. These galaxies, known as the blue compact dwarf or BCD galaxies, have also exhibited evidence of the new stars migrating inwards towards its center, adding to the galaxy's mass and volume. The team detected these star formation regions in 11 BCDs using the ultraviolet imaging telescope of AstroSat, India's first dedicated multi-wavelength space telescope aimed at studying celestial sources. Their findings, which have been peer-reviewed, were published in scientific journal Nature last week. The findings indicate extended star formation in the material that's coming together to form a dwarf galaxy. This is significant considering it is otherwise very hard to observe the formation of these early BCD galaxies as they are too small and faint and distant. AstroSat was able to observe these galaxies in both visible and ultraviolet light. This is the first time extended far ultraviolet disks have been observed in distant dwarf galaxies according to the study. We are now able to observe how dwarf galaxies in the comparatively early universe are acquiring their stellar content and are on their way to evolve into present-day dwarf galaxies, said Anshuman Borgehen, astronomer from Tezpur University, Assam, and lead author of the paper, in an email to ThePrint. This will help bridge the gap of understanding the diverse dwarf galaxy population that we see around us in the present day. AstroSat observes distant objects on the other end of the electromagnetic spectrum compared to the other space telescope that's making news, NASA's James Webb Space Telescope. While Webb studies faraway galaxies in various parts of the infrared wavelength, AstroSat observes objects in ultraviolet or UV, X-ray and visible light. NASA's Hubble Space Telescope also uses UV, visible as well as near-infrared regions. The light from distant objects is redshifted because of the expansion of the universe, which means that the further away an object moves, the more the visible light from it shifts towards the red end of the spectrum. In contrast, young stars that are just forming emit a majority of their energy in UV. Thus, galaxies that contain large clusters of young, hot and massive stars appear to be in blue in color and are thus named blue compact dwarfs. BCDs have been hard to study and understand as they are extremely compact and also very faint. Just like Webb, AstroSat is also capable of peering into the past, that is, observing light sources as they were billions of years ago when the light was emitted. The galaxies that were observed in this study have a look-back time of 1.3 to 2.8 billion years. The team also noticed that the UV disk extending from the center of the galaxy exceeded that of the optically visible disk of accreting material. Galaxies grow progressively faint as we go from inner to outer regions. So, to be able to detect emission in such regions, we require long observation hours, explained lead author Borgehen. Even Hubble's deep observations failed to yield data on star-forming regions in visible wavelengths. The detection of these star-forming regions in UV suggests they contain young stars because such stars emit predominantly in the UV wavelength regime. Also, since we don't see anything in the optical, it means that there are no old stars in outer regions, Borgehen said, adding, "Star formation seen in the outer low-density environments is puzzling because the gas in these regions is inefficient to form stars. Only the most recent outermost star-forming regions emit energy in far ultraviolet." These extended FUV disks are telltale signatures of galaxy disks that are accreting neutral hydrogen gas from the surrounding environment, referred to as the intergalactic medium, explained Borgehen. Another phenomenon that could likely occur here is passively existing reservoirs of neutral gas, according to Borgehen. Over billions of years, instabilities in the outer parts of this gas disk led to localized collapse of gas, igniting the region to form new stars. But these large reservoirs of neutral gas have not been detected around galaxies, especially with modern day powerful telescopes capable of detecting them. It is likely that present day dwarf galaxies around us have evolved enough to have exhausted the gas reservoirs, or that interactions with nearby galaxies would have destroyed it, speculated Bourgain. The clumpy structure of this less dense region also indicates that it is not gravitationally stable or uniform and is getting swept up in the rotating galaxy's forces and sucked towards its center. The findings provide a key step in understanding the evolution of BCDs, and the next step will be to understand how low density star formation regions occur around these dwarf galaxies and what drives them. We don't know whether our findings are special cases or a common phenomena, said Bourgain. We are planning a survey for these kinds of galaxies to build their statistical significance and also to find if we could have missed out on something. Thank you so much for listening to the Print Pod. We will be back soon with another episode.